Hi friends, in this video I'm going to demonstrate how to use the chain rule for differentiating a function. So here we want to differentiate y with respect to x. So you're obviously familiar by now with the power rule. Now the first thing that you notice here is that if we were to apply the power rule, we've got a power of 5. So the number in front of our bracket is obviously a 1. So 5 times 1 is 5. Then our power knocks off a point, then which is 5 minus 1 to give us a 4. But notice that when you do that, we have not paid any attention to the x squared plus 4, which in itself is a function. So what we have here is a function, let me call it f, which is sitting inside another function. So it is actually sitting inside the bracket function because note, as I've just explained, is that if suppose this was our x, suppose the bracket was our x, and this would just be x to the power 5, then your derivative using the power rule would just be 5x to the power 4. But recall what I said earlier, that when we use the power rule like that, we make no mention of this function sitting inside the bracket. So obviously, this is where the power rule fails because it fails to acknowledge the presence of the x squared plus 4. So we need another approach to finding the derivative. And this is where the chain rule comes in. So we take f to be our inner function, and then the outer function itself, we can call it g. And this is how we will proceed. So we want now to find, so let's first of all make a declaration that f is equal to x squared plus 4. However, finding the derivative of f alone, so in other words, we are finding the derivative of f with respect to x. So this is going to be 2x. And then we come back and we take our g. Now, notice that g is a bracket function. Normally, I advise people to write down this function, the bracket function, while leaving the inside empty, so that you picture this being just an x. Of course, I'm not going to write x, but I want you to picture inside the bracket having just an x. Then we can use the power rule as I have explained before. So if we use the power rule like this, that means we now have 5 bracket to the power 4. Now that we have found the derivative of g, we can put back the contents of the bracket. So the contents of a bracket is what? X squared plus 4. So I'll put it back here as well, x squared plus 4. Now we are ready to find the derivative because the derivative is our dy dx. Now, a simplified version of the formula is to simply multiply f prime by g prime. So let's see where that takes us. What is our f prime? Our f prime is 2x. So we're going to multiply 2x by g prime, and g prime is x squared plus 4 to the power 4. So we've taken note of that. So if we simplify this, that gives us what? 2 times 5 is 10. So we got a 10 there. And then we mustn't forget the x. And then we have the bracket x squared plus 4, and again to the power 4. And that is our derivative. Now, let's look at another one, another example. So now let's call this one example 2. So here we've got y equal to, so here we've got a radical function, 2x to the power 4 plus 7, like that. Right, so let's separate this from our previous example, okay? Right, so here we want to find dy dx. So the first thing you do here is to rewrite this function from radical form into exponent form. So this becomes 2x to the power 4 plus 7 to the power of a half. I take it that you guys know this relationship, that the square root of x in exponent form is x to the power 1 over 2. So this is the relationship that we're applying here. And the minute you do that, you automatically see that we've got an inner function, which we can call f, and then we've got an outer function, which we will call g. And we will proceed in exactly the same way as before. So we declare our f in this case to be 2x to the power 4 plus 7. And then we find the derivative. So 2 times 4 is 8. So this is 8x to the power 3. And this is a constant. The derivative of a constant is 0. Our g, remembering, of course, to just write the bracket at the beginning. I encourage this in order to avoid confusing yourself. Right, so now imagine that we have an x here. So it's more like x to the power of half. So we multiply, so it's going to be half times the bracket, and a half minus 1 leaves us with minus a half. So now that I'm done differentiating g, I can now put back the contents of the bracket. Right, so put back the contents of the bracket. And here, for now, we're done. So now we want to find dy dx. And remember, as before, it's going to be found by multiplying f prime by g prime. So what is our f prime? Our f prime is x to the power 3. So we're multiplying by g prime times a half 2x to the power 4 plus 7 to the power of minus a half. So let me just do this so that show the demarcation. Right, so 8 divided by 2 is 4. Then we got x to the power 3. Now notice here that this is a negative power. So in order to make it a positive power, I can bring it down to the denominator. So that comes 2x to the power 4 plus 7 to the power of a positive half, which of course, if you are good in algebra, this we can always rewrite it as the square root function now. So this is going to be square root of 2x to the power 4 plus 7. And here we are. And we are done. Right. I've got two more examples. Right. I've got two more examples. So this was example 2. So now we go to example 3. So what is example 3? It's 1 over cube root of 4x minus 3. It's 1 over cube root of 4x. So again, we want to rewrite this in exponent form. So this is going to be what? 4x minus 3 to the power of a third. But we need to bring this to the numerator. So we still have 4x minus 3. So our third becomes minus a third. And there we are. Same as before, we have got our inner function, we call it f. And then we have this outer function, we call it g. So we repeat the process. So f is what? Is 4x minus 3. So f prime will just be 4. Our g is a bracket function. And as I have said before, rather keep the contents of the bracket out for now until you have found g prime. So here it's minus 1 over 3 times the bracket. Now minus 1 over 3 minus a third is what? It remains negative, isn't it? So because a third is, sorry, 1 is 3 over 3, so it becomes minus 4 over 3. So now that we have found the derivative, we can put back the contents. So that is 4x minus 3. That is 4x minus 3. So here one needs to be really careful because our third was positive in the denominator and became negative in the numerator. So when we find, when we now use the power rule, it's a third minus 1, which is just minus 3 over 3. So minus 1 minus 3 becomes minus 4 over 3. So that is where the minus 4 over 3 came from there. Right. So we just come to this side now and find our dy dx. So our dy dx is found by multiplying our f prime by our g prime. And in our case, what is our f prime? Our f prime is 4, and we're multiplying by what? Minus 1 over 3. So notice that since this bracket is negative in the numerator, it becomes positive in the denominator. So we might as well bring it straight away to the denominator, and then it becomes positive 4 over 3. So this is negative 1 times 4. So we can put the negative sign here, and then we can put the 4 there. And remember, we've got a 3 here, and then that gives us 4x minus 3. Hopefully this time I will have enough space there. Yes, indeed, I do. So this is our final derivative. Right, I've got one more. I've got one more to share with you. So the next one, that will be my example four. And it is example 4, and it's the final one. Okay, right. So we have here y equal to 1 over x 5 minus 3x squared, like this. Right. 1 over, simplified, we can actually, because here the power here is 1, so we don't, we're not constrained. So we can multiply out. So this will give us 5x minus 3. Now, because it's 3x to the power 2 and this x to the power 1, so this is x to the power 3, which we can now bring to the numerator. We bring to the numerator as 5x minus 3x to the power 3 to the power of negative 1. So it's having a power of negative 1. So this is our inner function f, and this is obviously our outer function g. So let's rewrite this. So our f is 5x minus 3x to the power 3, and f prime would be, this is just the 5, minus 3 by 3 is 9. So this is 5 minus 9x squared. Our g, it's going to be just bracket for now, negative 1. And then g prime will be negative 1 bracket, negative 2. So now I can write in the contents 5x minus 3x to the power 3. And here the same, 5x minus 3x to the power 3. And we are done. So on this side now, we now want to find dy dx. So dy dx is what? Again, given by, oh, sorry, f prime multiplied by g prime. So what is our f prime? Our f prime is 5 minus 9x squared multiplied by negative 1. Well, I might as well, since the power is negative, I might as well just bring it down so that when it comes to the denominator, it becomes positive. So it's minus 2 there, positive 2 here. But now I must remember that I've got a negative here. I can put the negative in front like that. And then I take my 5 minus 9x squared divided by 5x minus 3x to the power 3 squared. Okay, and yeah, and that's it. Okay, so We just draw a line in demarcation so that you can see clearly. So this is our final derivative, and that's it.